Mobile Device Forensics by Mackenzie Elm. The purpose of the NIST guide is to provide basic information on mobile forensic tools, for example, preservation, acquisition, examination, and analysis. This guide will mainly focus on the characteristics of cellular mobile devices, feature phones, smartphones, and tablets with cellular voice capabilities. Who was this guide made for? Well, this guide is not focused on a specific target. The target can range from forensic examiners to response team members or organizational security officials, though readers are assumed to have the basic understanding of the traditional forensic methodologies. The practices recommended in this guide are here to highlight key technical principles associated with handling and the examination of mobile devices. Mobile devices can perform an array of functions ranging from a simple telephony to a personal computer. Both feature phones and smartphones support voice, text message, a set of basic personal information management type applications, including phone book and calendar capabilities. Mobile devices contain both non-volatile and volatile memory. Mobile configuration of mobile phones have evolved over time. Feature phones were among the first types of devices that contained NOR, flash, and RAM memory. System and user data were stored in the NOR and copied onto the RAM upon booting for faster execution. This was known as the first generation of mobile device configuration. Memory configuration evolved, adding NAND flash memory. This is known as the second generation. And the third generation is what we have now. They only contain NAND and RAM. Some more background can be SIM cards are synonymous with mobile devices that interoperate with GSM cellular networks. Under the GSM framework, a mobile device is referred to as a mobile station and is partitioned into two distinct components: the Universal Integrated Circuit Card and the mobile equipment. The UICC operating system controls access to elements of the filing system. Actions such as reading or updating may be permitted or denied unconditionally or allowed conditionally with the access right depending on the application. UICCs are available in three different size formats: the mini SIM, the micro SIM, and the nano SIM. The two most dominant style types of digital cellular networks are known as the Code Division Multiple Access, CDMA, and the Global System for Mobile Communications, GSM networks. Mobile IP is an Internet Engineering Task Force standard with communication protocol that allows mobile device users to move from one network to another while maintaining a permanent IP address. Some insight on forensic tools. The availability of forensic tools for mobile devices is considerably different than of a personal computer, but their functionality has become increasingly similar. The types of forensic software available for mobile examination includes commercial and open source forensic tools, as well as non-forensic tools intended for device management, testing, and diagnostics. Forensic tools are typically designed to acquire data from the internal memory of a handset and the UICCs without altering. The Mobile Device Tool Classification System. Understanding the various types of mobile acquisition tools and the data they are capable of recovering. First off is manual extraction. This involves viewing the data content stored in a device, information received, and may be recorded using an external digital camera. At this point, it is impossible to recover any deleted data. So logical extraction. Connectivity between a mobile device and a forensic workstation is achieved with a connection using either a wired or wireless connection. The data is sent back to the workstation and presented to the forensic examiner. Then hex dumping and JTAG. This is going to allow the forensic examiner more direct access to the raw information stored in the flash memory. A little more on hex dumping. This involves uploading a modified bootloader into a protected area of the memory on the device. This upload process is accomplished by connecting the mobile device's data port into a flasher box, and the flasher box is then connected to the forensic workstation. A little more on JTAG. Forensic examiners can communicate with the JTAG compliant component by utilizing the special purpose standalone programmer device to probe and define test points. The JTAG testing can be used to request memory addresses from the JTAG compliant component. Two more tools that can be used are the chip-off method. This refers to the acquisition of data directly from the mobile device's flash memory. This extraction requires the physical removal of the flash memory. Chip-off can provide the examiners with the ability to create a binary image of the removed chip. The microread. This involves the recording of physical observations of the gates on the NAND or the NOR chip with the use of an electron microscope. Due to the extreme technicalities this involves, this would only be attempted for high-profile cases like national security cases after all the other options have been exhausted. Obstructed devices. Software-based methods used to break or bypass authentication mechanisms have begun to appear. For instance, some tools provide an automatic function to recover passwords from locked mobile devices. Hardware-based methods involve a combination of software and hardware to break or bypass authentication mechanisms and gain access to the device. And then investigation methods are procedures the investigation team can apply which require no forensic software or hardware tools. For example, ask the owner, renew the seized material, and ask the service provider. Preservation. Evidence preservation is the process of securely maintaining custody of the property without altering or changing the contents of the data that resides on the device and the removable media. Securing and evaluating the scene. Incorrect procedures or improper handling of the mobile device during the seizure may cause loss of digital data. If the device is not handled properly, physical evidence may be contaminated and rendered useless. Documenting the scene. Evidence must be accurately identified and accounted for. Non-electronic material such as invoices, manuals, and packaging material may provide useful information on the capabilities of the device, the network used, account information, and unlocking codes for the PIN. A record of all visible data should be created. Isolation. Many mobile devices offer the user the ability to perform either a remote lock or remote wipe by simply sending a command, a text message, to the mobile device. Therefore, the forensic examiner needs to be aware and take precautions when securing a mobile devices, managing the chance of data modification. Packaging, transporting, and storing evidence. Once the mobile device is ready to be seized, the forensic specialist should seal the device in an appropriate container and label it appropriately according to the agency specifications. Storage facilities should hold the evidence in a cool, dry environment and in a sealed container in a secure area. On-site triage process. Triaging involves performing a data extraction on scene followed immediately by a preliminary analysis of the data extracted. Generic on-site decision tree. An on-site decision tree that may be used as a general guideline for organizations and agencies. This provides a starting point intended for customization, allowing alignment with existing policies and procedures. Acquisition is the process of imaging or otherwise obtaining information from a mobile device and its associated media. Performing an acquisition at the scene has the advantage that loss of information due to battery depletion, damage, etc. during the transportation and storage is avoided. Mobile device identification. Mobile devices need to be identified by make, model, and service provider. Clues that allow you to identify a mobile device can be device characteristics, device interface, device label, carrier identification, and reverse lookup. Tool selection and expectations. Once the make and model of the device are known, available manuals should be retrieved and studied. The manufacturer's website is a good place to begin. Mobile device memory acquisition. To acquire data from the mobile device, a connection must be established to the device from the forensic workstation. Before performing an acquisition, the version of the tool or device being used should be documented along with applicable patches or errata from the manufacturer applied to the tool. After the acquisition is finished, the forensic specialist should confirm that the contents of the device were captured correctly. Tangible equipment. Tangible equipment includes the device that contains memory and are associated with the mobile device. The three main categories are memory cards, host computers, to which the mobile device has synchronized its contents, and a cloud-based storage. Examination and analysis. The examination process uncovers digital evidence, including that which may be hidden or obscured. Some potential evidence could be subscriber and equipment identifiers, date, time, language, and other settings, phone book contact information, calendar information, text messages, outgoing, incoming, and missed call logs, electronic mail, photos, audio and video recordings, multimedia messages, instant messages, web browsing activities, electronic documents, social media related data, application related data, location information, and geological data. Generally, two types of computer forensic investigations take place. The first type is where the incident has occurred, but the identity of the offender is unknown. The second is where the suspect and the incident are known. Prepared with the background of the incident, the forensic examiner and analyst must proceed towards accomplishing the following objectives: gather the information about the individual who was involved, who, determine the exact nature of the events that occurred, what, construct a timeline of events, when, uncover information that explains the motive for the offense, why, and discover the tools or exploits that were used, how. Apply mobile device forensic tools. Once a copy of the acquisition results are available, the next step involves searching the data, identifying evidence, creating bookmarks, and developing the contents of a final report. To uncover evidence, specialists should gain a background of the suspect, offense, and determine a set of terms for the examination. Call and subscriber records. Records maintained by the service provider capture information needed to accurately bill a subscriber, or in the case of a preferred service plan, debit the balance. The records collected are referred to as the call detail records. Besides call detail records, subscriber records maintained by a service provider can provide data useful in the investigation. For example, GSM system, the database usually contains the following information about each customer: customer name and address, billing name and address, username and address, billing account details, telephone number, IMSI, UICC serial number, the PIN for the UICC, and the services allowed. Conclusion. Mobile device forensics is the science of recovering digital evidence and data from a device with a forensically sound conditioning and the using of the accepted methods. This guide helps give an in-depth look at the mobile device technologies in relation to their procedures. This guide goes over more than the surface level and gives you a real insight on many key topics. Overall, this guide gives a lot of deep knowledge about mobile device forensics and the procedures. I agree with this guide and have no comments about adding any additional information. This was written and formatted well, so you are getting the most out of your reading and understanding.